Hi students, so today we are going to discuss about hypothesis testing. We know that as managers, once you become business managers, leaders of the businesses, you need to know if the decisions that you have made are planning, which you have planned are going to be effective. So for example, you might need to answer the questions like if you have organized an advertising campaign, with the effect of that advertising campaign, with have the sales increased, and will product placement in a grocery store make a difference? Likewise, you have to answer certain questions when you become business leaders. So many applications of business analytics involve seeking statistical evidence that decisions or process changes have met their objectives. So most of the applications that we are using in business analytics try to find the evidences in order to check whether the decisions or the changes in the processes that you have made have successfully achieved the expected objective. So in order to do that, we are going to have derived certain statistical inferences. So the statistical inferences focuses on drawing conclusions about population from samples. So before going in depth as to what is hypothesis testing, you need to know what is meant by statistical inference. We'll look at what is meant by inference first. So inference simply means that you are going to draw certain conclusions about the population parameters based on the sample taken from the population. So due to the time and cost limitations, we are not going to have a census conducted. Instead, based on the sample, you are going to derive certain conclusions. So what you derive from the particular sample's conclusion, you are going to get the conclusion draw with regards to the population parameters based on the sample taken from the population. So if you look at this example, you can see we have taken a particular sample out of this population, and based on that particular sample you have derived a conclusion as to the sample mean is 149 grams. So if you are going to draw a conclusion with regards to this particular population, with regards to the mean weight of the apples in the population based on this sample, we say that you are drawing a statistical inference based on the sample. You are drawing a particular conclusion based on the sample, that we call it as the statistical inference. So there are key points for you to remember when you are drawing an inference. So first one is, a sample is likely to be a good representation of the population. So when you are drawing a sample in order to derive an inference with regards to the population, you have to be mindful of as to which sampling technique you are going to use. So based on that, you have to actually be mindful whether the particular sample that you are taking is a good representation of the population. The second point is that there is an element of uncertainty as to how well the sample represents the population. So there is an element of uncertainty associated with the sample, because we know that when we look at the population and the sample, there is a difference. So there is an element of uncertainty involved in the particular um, conclusions that you are going to based on the sample, but still we have to do it. And the way you have taken the sample matters, whether you have used the sampling technique, simple random sampling technique, systematic or cluster sampling technique. So that matters when you are drawing an inference. So what is this hypothesis? So we say that hypothesis is a proposition, or it's a tentative solution to a problem. So here, hypothesis is a tentative solution to a problem. It may or may not be correct. So we should be in a position to test the particular hypothesis. It has to be clear, it has to be precise, it has to be testable, and it has to be consistent with facts, and it has to be logical. So what is the difference between descriptive statistics and inferential statistics? In descriptive statistics, these are the statistics where we have the mean, mode, and median. So they are more like describing the data set that we have. But it's difficult for us to generalize beyond that based on the descriptive statistics, based on mean, median, mode. It's difficult for us to derive or to generalize with regards to the population, the facts regards to population. It's difficult for us to generalize it. When it comes to inferential statistics, these are statistics such as Ttest that allows us to make inferences about the population beyond our data. So based on these particular statistical techniques, based on inferential statistics, for example, Ttest is one of the inferential statistics. So these allow us in order to make inferences about the population which goes beyond our data set, which goes beyond the descriptive statistics. So when we talk about the t-test, so t-test we are going to discuss about one sample t-test, independent samples t-test, and dependent samples t-test. So this we are going to discuss in detail when it comes to the second, third, and fourth parts of the video. So hypothesis testing. So now you know what is an hypothesis. Hypothesis is a particular proposition, or it's a logical conclusion that you derive. So here it has to be consistent with facts. So these features are there in a hypothesis. So in hypothesis testing, what we do is that it is a technique that allows us to draw valid statistical conclusion about the value of population parameters or differences among them. So it's not like in descriptive statistics. In hypothesis testing, what we try to do is that it actually allows us to draw the valid statistical conclusions about the population parameters, or it may be about the conclusions about the value of the population parameters, or else it may be about the differences among the two populations. So if it is two sample t-test, it's going to be differences in two particular um, differences. We are going to based on differences if it is about two sample t-test. So that's what we do in hypothesis testing. So hypothesis testing involves drawing inferences about two contrasting propositions, each called a hypothesis, relating to the value of one or more population parameters such as mean, proportion, standard deviation, or variance. So when it comes to hypothesis, there are two basic hypotheses we talk about. One is the null hypothesis and the other one is alternative hypothesis. So when we talk about alternative hypothesis, there would be more than one alternative hypothesis as well. So when it comes to null hypothesis, in null hypothesis, what it does is that it describes the existing theory or a belief that is accepted as valid unless strong statistical evidence exists to the contrary. So in null hypothesis, what you do is that you are going to base your logical statement based on the existing theory. That means that has been the belief until now. So in alternative hypothesis, it is a complement of the null hypothesis. So what you are doing in alternative hypothesis is that if the null hypothesis is rejected, you are in a position to you will have to accept a particular alternative hypothesis. Okay, so in null hypothesis you have to base your logical statement, the null hypothesis statement, based on an existing theory or a belief. The null hypothesis is denoted. The notation for null hypothesis is H naught. You all can see here. So, and the alternative hypothesis is derived as H alpha. Or if there are more than one alternative hypothesis, we can use the notations as H1, H2, H3. Likewise, we can use the notations. Uh, and reject null hypothesis and conclude that sample data provides sufficient statistical evidence to support the alternative hypothesis, or fail to reject null hypothesis and conclude that sample data does not support the alternative hypothesis. So if you fail to reject the null hypothesis, that means you have to conclude that the sample data that we have taken does not support the alternative hypothesis. In other words, you are accepting the null hypothesis. Let's look at this particular example. It is believed that a candy machine makes chocolate bars that are on average 5 grams. A worker claims that the machine after maintenance no longer makes 5-gram bars. Write H naught and H alpha. So here, uh, what has been the belief until now? So it should be the null hypothesis. So what has been the belief until now? That H naught. So when you are writing the null hypothesis, it's H naught. Naught has to be subscripted. H naught and colon. So colon has to be superscript again. Superscript means it's uh, okay, not superscript, it should be normal font. So H naught equals, it is believed that candy machines make chocolate bars that are on average 5 grams. So if it is average, average means mean. So here in the hypothesis statement, we are referring to the population mean. So if it is population mean, we know in statistics we have learned that the notation for population means is mu. So let me add it in symbols. We have the population mean. So mu here, mu. So the belief has been until now it is 5 grams. So what has to be the alternative hypothesis then? It has to be here, it should be H alpha. I have H alpha here, sorry, symbol alpha. Mu is not equal, so this has to be cut cross. Let me check whether we have this. So I have done it here. So this particular symbol. So that is our alternative hypothesis. So H naught is H naught, that is our null hypothesis. Its mu equals 5 grams because it has been the belief until now. And what the particular worker tries to do is that he had claimed that the machine after maintenance no longer makes 5-gram bar. So that's going to be our alternative hypothesis. That is what we are going to test. So I hope the null hypothesis and alternative hypothesis is clear for you all. So here it says, if we fail to reject the null hypothesis, then we can only accept as valid the existing theory or belief. So suppose that once after we have conducted the hypothesis testing, and if we fail to reject this particular null hypothesis, that means we have to accept the belief that has been believed until now to be true as the accepted one. So when I'm explaining here, it might not be clear for you, but when we go into Ttest, when we are doing practice questions, it would be more clear for you all. Okay, so don't worry. So these are the steps in hypothesis testing with decision making rules. So these are the steps that you have to follow when you are going to make a decision based on hypothesis testing. Step one is you have to state null hypothesis and alternative hypothesis. So when a question is given, when you have to make a decision, first you have to state the null and the alternative hypothesis. So here hypothesis is, it's the plural of hypothesis. And step two, set the alpha level. So most of the time we are setting the alpha level as 0.05. So if it is a question, I would be giving what would be the alpha level. So most probably it would be 0.05. And you have to select the statistical test. So in order to do hypothesis testing, you can either go for a t-test, ANOVA, or a regression analysis. So since we have already covered the regression and ANOVA, this particular lesson we are going to focus on the t-test mainly. So here you have to select the statistical test and then conduct the statistical test and obtain the p-value. So when it comes to conducting the statistical test and deriving the p-value, you have to remember that this is only one method for you to do the hypothesis testing based on may it be t-test, may it be ANOVA, or may it be regression analysis. So based on the p-value, either you can take the derive the statistical inference, or else you can based on the critical value method also you can derive the particular result. So then it is said that compare p-value to the alpha level. So here uh, in decision rule 1 and decision rule 2, they have derived the results based, they have derived the results, they have rejected the null hypothesis or accepted the null hypothesis based on the p-value. So if the p-value has been less than or equals to 0.05, they have rejected the null hypothesis and alternatively accepted the alternative hypothesis. So if the p-value has been greater than alpha level, they have that means they have failed to reject the null hypothesis. That means they have accepted the null hypothesis. So this is one way, and the other way would be based on the here. This is method 1, and the method 2 is based on the critical value method. So we are going to look at the bell curve and we are going to look at the critical values, and based on the T statistics we have to derive the particular results. So both the ways I'm going to explain you in the one sample t-test. So when I'm explaining it, you would understand. So that is the basics of the hypothesis testing. So I hope what is meant by statistical inference is clear for you. What is a hypothesis is clear. Hypothesis testing is clear. So what are the things that you have to be mindful of when you are drawing a statistical inference? I hope it's clear for you all. And the null hypothesis and alternative hypothesis we have discussed by now. So in the next video, I'm going to, so here, look at this one. This is normal probability curve. So here, this is the non-rejected area, this area. So 0.05. This side we have the 0.05. So this we would be explaining in the next part of the video as well. Just have an idea as to this is the rejection area and this is the accepting area. Okay, non-rejection region and rejection region. Okay, so we'll be meeting in the next part of the video with regards to one sample hypothesis testing using Excel. So thank you. We'll meet in the next video.